Okay, so this is the review. So my goal here is to kind of maybe try to hit at least one of each kind of category. But again, any that I don't get to or anything like that, again, you can see the completed copy on its learning. Right? All right, first up is graphs and domain and range. So number one, right? You've got an equation and it wants us to graph it. Actually, let's start, I think maybe number two would be better to start with. Okay, so let's look at number two. So it wants us to graph this, and it also wants us to find the domain and range. There's a couple different ways to graph these. One is I showed you how to use transformations to make a graph. I showed you how to do that, okay? The other way to do it is to just type it into Desmos and get a table of values, right? So most people prefer just getting a table of values in Desmos, so we'll do that. So to graph this, we're going to type it in, y equals 2 square root x, and then click out of the square root to do +1. Now, if you're going to do these, the first thing you need to do is zoom in and find the starting point. So if I kind of zoom in real close here, zoom in until you think you can actually see the points of the starting point. If I zoom in, where's the location of my starting point here? Okay, well, what's the coordinates of it? 0, 1. So my starting point is here at 0, 1. Okay, that's my starting point. Okay, so now you've got a couple options, okay? One, you can use transformations to find the next point, or you can just click on Desmos. You can click on the gear after you've typed in the equation. Click on the gear, and then click on the table. So again, that's gear, and then click on this table icon, okay? What I recommend you do is as soon as the table comes up, delete everything, okay? And then start at the starting point. So our starting point started at what x value? Because we're typing in an x value here. What x value does the starting point start at? 0. So start my table at an x value of 0, since that's my starting point. And then just run down the list. So if I start at 0, the next x value would be 1, 2, 3, 4, and so on. And then just see if there's any nice, easy points to graph. So we have 0, 1. Another nice, easy point is 1, 3. And then another one is at 4, 5. And then from there, just kind of follow the natural curve of the points, and we've got our graph. Okay, so we've graphed it. So now let's find the domain and range. All right, so domain, again, is left to right, x values. It's my x values left to right. So what you do to find the domain is you go to the leftmost point. Here's my leftmost point here. What x value does that have? 0. So my x values start at 0. Find the rightmost point. Well, the rightmost point is an arrow. So what's the infinity? So if the rightmost point is an arrow, it's going to go to infinity to the right. So my domain would be from 0 to infinity. Okay. Next, my range. Okay, my range is bottom to top. My y values bottom to top. So you find the bottommost point, and what's its y value? So here's my bottommost point here. What y value is that bottommost point have? 1, okay? So the bottom point has a y value of 1, so my range will start at 1. Then you find the topmost point. Well, the topmost point is an arrow, so the top will be up to where? Infinity. And there's our range. Okay. So we found our domain and range for that as well. All right. Again, just another reminder about the note card. Okay. The note card is designed to give you a little bit of guidance on questions, right? So you could put one example of every single type of question on there. You could put just the stuff that you think you might forget on there. Okay. I'm a bit over seeing half the class not even bother making one. It's just kind of sad. Okay. Uh, uh, what other math class have you had where they just gave you access to a full formula chart of your own making? Okay, y'all are better than that. Make a note card. All right. All right. So now you've got your domain and range. So graphing and domain and range is on there. Next, transformations. Transformations. All right. So what transformations do the following functions have compared to the parent function? Okay. So these are square root equations. The parent function is y equals square root x. That's the parent function. All transformations come from that. Okay. Now, let's review the rules for transformation. So for the rules for transformations, okay, start from the square root equation transformation form. So a square root x plus or minus h plus or minus k. This is the transformation form that we've talked about for the transformation rules. Again, the transformation rules, right, are the same for every single function we've ever done in this class and will continue to do in this class. Okay, these are not new, right? So let's review the transformation rules. First, the a value. Okay, the first transformation that the a value can cause is when a is negative. So if a is negative, what transformation does that cause? Okay, we need a review. Okay, so here's square root x. Let's put a negative in front. Negative square root x. What's the difference? What happened? It flipped it. What's the word, the math word for flipped upside down? Reflection, okay? So a negative a value makes it flip upside down, reflection, okay? So that's called reflection. Okay, next, the next option is the a value number could be between 0 and 1. The a value number could be between 0 and 1. So for example, what's an a value between 0 and 1? Yeah, 1/2. Sure, 1/2, 1/3, right? So if I put a 1/2 in front, what do you say happens to the graph? What happened there? It got smaller, it got squished, so compression, okay? So when a is between 0 and 1, it is a compression. Next, if the a value is bigger than 1, so for example, what's a number bigger than 1? 2. What's the difference there? It got taller, it got stretched up, okay? So it's called a stretch. All right, next, inside the x plus or minus h. Okay, so let's say you could have x plus or minus h. So let's say it was an x plus 1. What's the difference there? If I added an x plus 1, what happened? Okay, it went to the left. Okay, so it goes, if it's x plus h, so if it's an x plus h, it will go left that many places. Okay, if I make it x minus 1, what happened there? If I made it x minus 1, what happened? Went right 1. Okay, so x minus h makes it go to the right. Last, the k value. This k value. So let's see what this does. If I make it a square root of x and at the end I put a plus 1, what happened? It went up. Okay, so it went up 1. So if it's a plus k, it will go up. And then if I make it like a minus 1, what happened if I did minus 1? It went down. Okay, so a minus k makes it go down. These are the rules. If you think you might forget these, what would you do? That's what the note card is for. Okay, you just put those on there, and then you don't forget them during the test. Okay, so if you're worried you'll forget them, that's what I give you a note card for. Okay, so those are transformations. Rules. Let's do a couple of examples using them. So number 3. Okay, so we have our a value is negative 3/4. We have an x plus h inside, and then we have a minus k outside. Okay, and our a is negative. So we have a negative a value, we have an x plus h, and then a minus k in this case. Let's go through. First off, a negative a value causes what transformation? Reflection. Okay. Then my a value number is 3/4. So 3/4 is between 0 and 1. Okay, so that would be a compression. Then we have an x plus 2, so that's an x plus h. So an x plus h, according to our rules, will do what? Left. Okay, so this will go, it's x plus 2, so it'll go left 2. And then finally, I have a minus k value, in this case a minus 5, so that would go down 5. Okay. All right, let's see. Let's go to the next little section here. So the next section is the reverse. I'm going to give you transformations. You're going to give me an equation. So let's go to number 8. All right, so number 8. Actually, let's do number 11, actually. I like number 11 better. Okay, let's go through each one. Vertical stretch by 5. Vertical stretch by 5. What part of the equation makes a vertical stretch? A, H, or K? Okay, so we can come up here and check. Where do we see stretch? Okay, that means the A value. Okay, so here, a stretch by 5 means A would be 5. Down 3. What part of our equation causes it to go down? So here's our rules. Where do we see down? What part of our equation makes it go down? Minus k. So if I have down 3, it would be a minus 3k value. And then I have reflection over the x-axis. So where in our rules do we see reflection? So that means the a value is negative. Okay, so our equation then will be negative, our a value is 5, square root x, and then a k value of minus 3. Done. That right there has a reflection, stretch by 5, down 3. There's my transformations. Okay. Let's do one more of these. Number 8. So if you need to write down the formula, you can. A square root x plus or minus h plus or minus k. If you need to write it down, that's fine too. All right, let's go through each one. Reflection over the x-axis. What part of the equation would make that happen? What about the a? Okay, so it'll be a negative a value. Then a vertical stretch. What part of the equation makes it stretch? What about the a? They don't give us a number. So what a value would make it stretch? Bigger than 1. Okay, so a stretch, a needs to be bigger than 1. So what's a number bigger than 1? 2, or 1,157. Okay, so a stretch would make an a value of like 2 or 3 or 12, right? Then we have left 1. What part of the formula makes it go left 1? The h or the k? Okay, so then if I wanted to go left 1, what would I need to put in here? Here's left. So if I want to go left 1, what would I need to put in there? Okay, but what would my h value be if I'm left 1? Okay, so left 1 would be x plus 1. And then finally, I have down 5. What part of the formula makes it go down 5? Okay, the k value, so minus k would make it go down, so minus 5. And we're done. So we're just writing the equation from the transformations, the reverse of what we did earlier. Okay, let's go to solving. So the steps for solving, let's write the steps out. Step 1, we need to isolate the square root. Okay, so the steps for solving: isolate the square root, step 2, square both sides. Step 2 is to square both sides. Step 3 is to solve for x, or whatever letter they chose. Solve for whatever letter they chose. And then step 4 is to check. Okay, let's look at number 13. Now in this case, we have 2 square roots. That's fine, just pick one. Okay, pick a square root. So let's say we do this one. Okay, step 1 is to isolate it. Is it already isolated, or is there stuff attached to it outside? Yeah, nothing else. It's not like a 2 square root. It's the square root's by itself. Okay, so step 1 is done. Step 2 is to square both sides. So now both sides we will square. So now on the left-hand side, a square and a square root can cancel each other. So a square cancels the square root, and we have b over 3 equals. On the right-hand side, we have another square and a square root. So again, those will cancel, and you have 2b minus 15. So that's step 2. We squared both sides. Step 3 is to solve for the variable. So in this case, the variable is b. We're going to solve for b. To do that, we're going to isolate. We're going to get the variable by itself. Well, look at the b. Here's a b. It's not by itself because there's a divide 3 attached. So how do I get rid of a divide 3? Times 3. So get rid of this divide 3 by doing times 3 to both sides. So multiply that whole side by 3. So then on the left-hand side, the 3's cancel out, and we have b equals. On the right-hand side, the 3 times by both of those would be 6b minus 45. The 3 will times both of those. This is now just a normal Algebra 1 solving problem. I've got a variable on both sides. So if I have a variable on both sides, I need to move one of them. So I'm going to minus the, I'm going to minus the 6b over to here. So I have 1b minus 6b makes negative 5b equals negative 45. Divide by negative 5, and so b would be equal to 9 when I divide by negative 5. Okay, now this is step 3. We solved for the variable. Now step 4 says check. Okay, I'll try to make this as clear as possible. The answer you get here is correct most of the time. Okay, so if you get this far, you will be right most of the time. Okay, and that's great, right? However, if you want to be right 100% of the time, you need to make sure to check your answers, because sometimes in some cases it just doesn't work, right? So this is right most of the time, but to be right all of the time, we should check our answer. Okay, so let's do that real fast. So now we're going to check. So to check, right, we're going to take this original equation before we did anything. So take that original equation, square root b over 3 equals square root 2b minus 15. So take your original equation and to check it, you're going to replace the variable with the number that you found. So I'm going to replace the b with 9 and see what happens. So the left-hand side is square root, and then b is replaced with 9, so it's 9 over 3, equals, the right side is square root, 2 times b is replaced with 9, and then minus 15. Now, an answer is correct in an equation if the left side is the same as the right side. So I need to calculate the left side, see what I get. Calculate the right side, see what I get. And then see if they're the same thing. Right? So calculate the left side. You can just type it into a calculator. Square root 9 over 3. So the left side calculates to about 1.73, blah, blah, blah. Calculate the right side and see if it's also the same thing. So if I calculate the right side, square root 2 times 9 minus 15, I get also 1.73, blah, blah, blah. I calculated the left side and the right side. Are they the same thing? Okay, so then yes, that 9 is a correct solution. Again, the answer you get is correct most of the time, right? But we want to make sure we're right all the time, so we're going to check our answers as well. Okay, I'd like to do one more solving one real fast. So let's go to number 14. Okay, so for number 14, first isolate the square root. So we have a square root right here. Is there anything else attached to it outside? Okay, so step 1 is done. Step 2 is to square both sides. So on the left-hand side, the square can cancel the square root, and we get 63 minus 2x equals. On the right-hand side, there's no square root to cancel the square. So this is just x squared is just x times itself, which is just x squared. Okay. So the left-hand side, the square cancels the square root. The right-hand side is just x squared, so x squared. Now, at this point, we learned that sometimes, at this step, sometimes we get easy algebra 1 problems to solve. In other times, we get harder problems to solve. What makes this one harder? Why is this one harder than the previous one? Okay, this x squared makes it a quadratic. Quadratics are always harder than regular equations. Okay. Because that is a quadratic, we need to make it equal to 0 and factor to get the solution. So because this is a quadratic, we're going to have to make it equal to 0 and factor it to get the solutions. You only have to do this if it's a quadratic, which is why we spent an entire unit only solving quadratics. Okay. Okay, so to make it equal to 0, first I want to make sure this stays positive. The square term should stay positive. So I'm going to just add this 2x over and minus the 63 over. So 0 equals x squared, add the 2x over, minus the 63 over. And now it's equal to 0. So it's equal to 0 now. Now I can factor it. So to factor it, my a value is 1, b is 2, c is negative 63, and then I make my factor table. A times c is negative 63, b is 2, what two numbers multiply to make negative 63 but add to make 2? Yeah, negative 7 and 9. Good. Negative 7 and 9. Multiply to make negative 63 and add to make 2. So then my factors are x minus 7 and x plus 9. Now, technically, you need to divide by a, but if our a value is 1, will dividing by it change anything? Okay, so factoring is done. But these are only the factors. What then do I do with factors to get solutions? It will, but why? What do we do with it to make that happen? Okay, so set them each equal to 0. So if I set it equal to 0, I'll add the 7 over, and yes, it'll become positive 7. Over here, I set this equal to 0 and minus the 9, and it will become negative 9. So those would be my two solutions. Now, these are, again, possible solutions. These are correct most of the time, but sometimes they're not, right? So if you want to make sure you're always right, right, and answer choices can sometimes try to trick you, right? We should check our answers. So let's also go ahead and check real fast. So to check, we're going to take our original equation, square root 63 minus 2x equals x. So take the original equation, and we're going to replace x with the number that I want to check. So let's check each one separately. What's the first answer we got? 7. Okay, so let's check 7. So square root 63 minus 2, x is replaced with 7, equals x is replaced with 7. And again, an equal sign means the left side should be the same as the right side. So let's calculate the left side. Square root 63 minus 2 times 7. So the left side calculates to 7. The right side is just already 7. So is the left side the same as the right side? Okay, so 7 is a correct solution. So down here, 7 is a correct solution. But we need to check the other one as well. So we need to check 9, negative 9. So square root 63 minus 2 times x is negative 9 equals, again, x is negative 9. Let's check to see if the left side calculates to the same thing as the right side. So the left side, we can type it in. The left side calculates to 9. The right side is just negative 9. Is 9 the same as negative 9? No. Okay. Gaining $9 is not the same as losing $9. Okay. These are not the same. So no. All right. So what this means is, what does this mean about this solution, negative 9? That's not a solution. So let's say if this is a multiple choice question, answer choice A might be 7. Answer choice B might be negative 9. Answer choice C might be 7 and negative 9. Which one would you choose? If answer choice A just said 7, answer choice B said negative 9, answer choice C said 7 and negative 9. Just 7, so A, okay? Okay, so that's solving. I'll let you try those other two on your own, and you can check the key online. Let's go to inverse equations next. Let's do number 17. Okay, first let's do the steps for inverse equations. So steps for inverse equations. Step 1, switch x and y. Step 2, solve for y. So those are the steps for inverse equations. Okay, so number 17. First, don't let the f of x throw you off. F of x is just a fancy way of saying y. Okay, so if the f of x confuses you, just replace it with y. Now, step 1 is to switch x and y. So x and y will switch places here. So then I have x equals y minus 4 squared plus 1. All right, so now step 2 is to solve for y. So to solve for y, the first thing I need to do is isolate this piece here. So you'll either isolate, it's like solving, it's just like solving, right? You're going to isolate the square or the square root. So to isolate that, I'm going to minus the 1 over. So x minus 1 equals y minus 4 squared. Now again, I'm solving for y. So I need to get rid of this square. How do I cancel a square? With a square root. So I cancel a square with a square root. So I square root both sides. So on the left-hand side, that's just square root x minus 1. On the right side, the square would cancel the square root, and we just get y minus 4. And now finally, to get y, to solve for y, I get rid of the minus 4 by adding it over. So then I've got square root x minus 1 and then plus 4 equals y. This is the correct inverse equation, okay? The last thing you just need to be aware of, I don't care if you do it on a multiple choice or whatever, is you need to be able to label it as an inverse. So all you do to label this as an inverse is instead of putting y, you put f to the negative 1 of x. And that's it. Again, the f to the negative 1 is just the label for inverse. It doesn't do anything, right? It's just the label for inverse. And we're done with that question. Okay. All right, I've got time for one more. So the last one I'd like to do is going to be number 22. Again, number 21, it's important that you do number 21 on your own tonight, okay? Look at the key, look at the notes for graphing inverses, okay? That is on the test. I'm telling you right now, that is on the test, but we don't have time to talk about it right now. So make sure you study that and prepare for that by going back to 6.6 notes or looking at it on the review, but make sure you can do 21. However, I think 22 is harder, so let me briefly talk about 22 real fast, and then we'll be done. Okay, so number 22, find the inverse algebraically. So again, we're finding the inverse equation, just like before. So f of x is the same as y, don't let that throw you off. To find the inverse equation, you switch x and y. So x equals negative 3 plus 1/2 square root y plus 5. We're solving for y, so we're going to have to isolate the square root. So I'm going to need to get rid of the 1/2 and the negative 3. So let's add the 3 over. So we get x plus 3 equals 1/2 square root y plus 5. Then the easiest way to get rid of a fraction, we talked about this on Friday, the easiest way to get rid of a fraction is to just multiply by its denominator. So to get rid of this fraction, I would just times by its denominator to both sides. So if you've got a fraction, the easiest way to get rid of it is to just times it by its denominator. So the denominator 2 will cancel with the 1/2. On the left-hand side, I times by 2 to get 2x plus 6 equals square root y plus 5. So the easiest way to get rid of a fraction is to just times by the denominator. Then I get rid of the square root by doing its opposite. So I get rid of a square root with a how do I get rid of this square root? What's the opposite of a square root? square. So I square both sides. So then I have 2x plus 6 squared equals, and then square cancels the square root, y plus 5. The good news is, since we're just trying to create an equation, we're not actually trying to get a single number out of this. You don't need to actually distribute this. You can leave it alone. Just leave it like that. That's fine. So you can just leave it like that, and then you can get y by itself by subtracting the 5 over. So 2x plus 6 and then squared is equal to y. Oh, sorry, minus 5. Oops. Minus 5 is equal to y. And that's my inverse. So down here, it wants us to label it with this -1, which just means inverse. So I just f inverse of x is equal to 2x plus 6 squared minus 5. Okay, so that is that. Again, if you need any extra help with with it, make sure you follow the key on the review key on its learning, or go back and watch old lesson videos. Thanks.